she is she was formerly, used to be, a pole vaulter. And she claims that she can still pull off a few pull-ups with her kids hanging onto her. So I think that's a challenge accepted. You need to do that. Please, everyone, welcome to the stage, Major Maxine.
And I told Jared that I would be happy to show the pull-ups, but I'm in uniform, so it'd be impractical. So that's my excuse. And I am Major Maxine Drake. I am coming to you to talk about my lessons learned, my personal lessons learned from the one of the Army's COVID-19 models, projection models. Now, this is not the official Army model. This is one projection model of a few that we have in the Army that is large scale, and it has informed the senior most Army leaders. Today I will, first I'll tell you who I am, go over a personal introduction. I will discuss our model briefly, describe to you what it is, and then go over some coding lessons learned that I hope will be of some use to someone in the audience. And finally, I'll discuss some project management and team management observations I've made over the course of this project. I am, like I said, active duty. I am an operations researcher. That is my career field in the Army. As an operations researcher, I am serving as a data analyst for the Center for Army Analysis here at Fort Belvoir, Virginia. Before being what we call an ORSA, analyst, I was an engineer officer. So I served as an engineer officer, as a platoon leader, an executive officer, a company commander, all in combat engineer units. I've served in North Carolina, Louisiana, and Afghanistan. I went to West Point, United States Military Academy, and graduated in 2009 with a bachelor's in economics and Russian. Later on, I went to George Mason University and got my master's in operations research. That is where I started using R. So in around 2017 is when I started. Our model. So I'm going to summarize it briefly, but first I didn't mention this is an IO slide presentation, and I'll give a quick shout out to Mallory, who really sold it last time when she gave her presentation using a dashboard and inspired me to use R to generate IO slides and dashboards. Our model, like I said, its purpose is to project COVID cases, estimate future COVID cases, and at its core, it is a SEER model. SEER stands for susceptible, exposed, infected, and removed. It is a standard epidemiological model, and it's what epidemiologists call a compartmental model, which means the entirety of a population that you're modeling falls into one of, in this case, 4 bins. First, individuals are in the susceptible bin, which means they're vulnerable, have never been in contact with the virus. Then individuals move into the E bin, which is exposed. That means they've come into contact and they're incubating the virus. Then individuals move into the infected bin, which is individuals are actively infectious or contagious, and whether or not they're symptomatic. And then finally, they move into the U bin, which is what we call the removed bin, which means individuals are immune to the disease or virus and no longer susceptible. Of course, there are a lot of assumptions here. I'm not going to really talk about those because that would take a long time. I do want to touch on a couple other things about the model, which is we have what I would describe as a submodel. It's our primary submodel, which is an XGBoost model that estimates future R0 values, R0 being the basic reproductive rate of COVID, of the coronavirus. We train the model on several data sets, about 30 different variables from data sets including population mobility, state policy, population demographics, and of course, COVID-19 case trends. We have a couple other smaller scale submodels or calculations that we use to update parameter values and initial values for the model each day that we run it. We run this model for every county in the United States, and we run it again for every county and core-based statistical area, which is effectively a group of counties. So I'll talk to you about some coding lessons learned. If you're a programmer out there, bear with me. You are aware of my academic experience, and I did not learn R through a programming lens. Some of this might not be relevant to you. However, I'm hoping that there's someone out there like me 1 year ago who didn't fully realize certain benefits to what I'm about to talk about, function, and then later on some new packages that I learned. So function, I realize function is old news. So I'm not here to talk about what function is and how to use it, but I do want to talk about the benefits of using function and modularizing code that I didn't fully recognize, like I said, 1 year ago. So our model began as one script, one long run-on script is how I would describe it. What we did is we modularized, the first thing we did is we modularized the code. So we organized it into purpose-specific or task-specific chunks and then translated those chunks into functions. So each function has a specific task. And at the end, I'll highlight, and what I show here are our functions. You can't see what goes on in the functions, but you can sort of get a gist of each one of these has a task. The first one, not surprisingly, downloads daily data, as the title suggests, or the name suggests. The last one I'll highlight is called SEER modular, and I'll talk about this one later on. This is our wrapper function. And this is where we set all the default argument values that we want the model to use most frequently. And it dictates the sequence of those preceding functions that we want the model to be routed through. So more on function, because I have a new love for this capability. So first of all, functions allow us to expand our mental model. And by that, I mean, in the beginning, when we had one long run-on script, we had to conceptualize the entire script all at once, the whole model all at once. Once we modularized it and turned it into task-specific functions, we really just had to conceptualize one task or one function at a time, which allowed us to make the model larger and more complex. Second, it made our model more flexible. So instead of hard coding values into our script, we could now use arguments and run the function using arguments, using whatever parameter values or coefficient values that we wanted when we run the function. So take this one step further, and instead of changing an argument value from, say, 4 to 7, we can also change it from 4 to a vector or a list of values, which made solving these functions or executing these functions iteratively possible. It also made performing these functions in parallel possible as well, using the furrr package, which I'll touch on in a moment. We were able to replace entire functions, sort of like swapping a car part. So if the structure of the input was the same and the structure of the output, what came out of the function, was the same, then it didn't matter what happened inside the function. So we could generate an entirely new function if we were developing the model with some new capability. And then when we were ready, we flipped the switch and we told our wrapper function, use function A instead of function B, or vice versa. What we did was we took our core scripts, a couple of our core scripts, and we made them entirely comprised of functions. And then we sourced these scripts. This was good practice. What I learned is it was good practice for a couple different reasons. First is that we were going into those core scripts less often, because whenever we had to go into model development or run the model or troubleshoot, we didn't need to do it in that core script anymore. We just needed to source that core script and run those functions elsewhere. So it meant fewer changes to those core scripts, which made merging in Git a lot simpler. The second reason this making these sourceable scripts was good practice was that it allowed us to use these functions in other areas of our analysis. So now we were able to do validation and verification by using those core model running scripts, but for a completely different purpose. And then finally, I can't go on without saying that our objective is to make a package. We're in the preliminary steps, but we need a bit more bandwidth to finish that. So a couple packages. One, of course, Tidyverse. I'm not going to talk about Tidyverse because I'm comfortable. I'm sure we are all comfortable with the role Tidyverse plays in our coding. And if it's new to you, please look it up. What I will talk about is furrr. So furrr allows one to execute a function in parallel over multiple cores on your computer. So what I've done here is I'm going to take you through just a very simple sequence of how a simple function gets translated into a furrr function. So the first example here is, and I'll go ahead and show all of them. The first function here is we're running that wrapper function I mentioned earlier, cir_modular. And I'm running it in this first chunk using one singular FIPS. A FIPS is, in this case, a county code, and one singular date. This is the simplest way to run a function. We're running the model with these two inputs, arguments. The second chunk runs the cir_modular model. No, I can't talk right now. Please can't. Thank you. As you can see, I'm teleworking, so my kids don't appreciate that much. Anyways, so the next example is the purrr. So we're running cir_modular over a vector of FIPS and a vector of dates. This purrr performs executes cir_modular iteratively, similar to a for loop, but it's a little cleaner, I'd say, than a for loop. Then the last chunk is translating that into furrr. So just like before, we're solving cir_modular over a vector of FIPS and a vector of dates. We set a plan. So we tell for how many cores we want to execute the functions over, and then we use furrr to execute cir_modular. And it's a simple translation from purrr. If you're comfortable with purrr, all you have to do is add future at the beginning of the function, and it's a simple translation. So because it's working in parallel rather than iteratively, it is a lot faster. And I ran one chunk of our model using 4 different functions. One was furrr using 8 cores on my laptop, and it was the future IMAP_DFR function. I also used purrr, IMAP_DFR, lapply, and a for loop. You can see the latter 3 are took very close to the same amount of time. Purrr was slightly faster, but furrr was just significantly faster. Yes, less than half the time when using 8 cores. So I talked about the technical highlights from our code and our model, but I also want to touch on what I hope will be interesting to this audience, which is some observations I had of our management in organizing and communicating our analysis and managing our team. I'll use a couple different terms. So there are a couple groups of people I'm going to refer to. One is our management, and that is our boss, effectively. We had a couple different people who were leading our team, who organized our analysis, who gave us direction, us being the modeling team, and then communicated that and briefed that to senior leaders. Senior leaders are the other group I'm going to talk about. Senior leaders are those whom we informed. They were our customer, if you will. And those are the senior leaders of the Army. They include the Vice Chief of Staff, the head of operations and planning for the Army. And so I just don't want you to get confused on those two groups that I'm about to talk about. The way I would characterize our management's approach to informing the senior leaders was their attentiveness to the senior leaders' decision cycle. So first was a willingness to defer improvements in precision. The way I would describe that is a late answer to a problem is a non-answer to a problem. And I'm sure that's not just true in the Army, but I can really only speak for my experience in the Army. So under duress, by that I mean under duress, senior leaders will always prefer a less precise information to no information at all. This is difficult for us analysts to accept because we always want our work to be as precise and accurate as possible. So there's a trade-off, and this is what our management really thought hard about, is the trade-off between timeliness for the sake of meeting a decision maker's timeline and precision, because that is one of our goals as analysts. And they were able to understanding the model and our analysis, as well as the senior leaders' decision environment, allowed them to make informed decisions and weigh those competing priorities effectively. Second, eagerness to anticipate likely questions. So generally speaking, what I've noticed is by the time the decision maker knows what he or she needs to make decisions or make a specific decision, there may not be enough time to develop the informative and actionable analytics, or in our case, to develop the model accordingly. So our team management accepted some risk in developing and executing the analytics before an official tasking or question came down. So basically, this meant we could answer questions faster. For me and the rest of the modeling team, there were about three or four of us on the modeling team at any point in time. For us, this meant we were constantly in development mode and production mode at the same time. Remember how I said when we modularized the code, we were able to swap functions like car parts. This ended up being very useful because we had our production model, and we were able to develop functions that would replace a specific task function, and then tell the wrapper function to route the model. We flip that switch, route the model through this new function that we had developed. Of course, we also used Git to create new branches when developing. But this ended up being a pretty handy way of keeping the model flexible. Third was the attentiveness to the actual requirements of the decision maker. And so what I mean by this is decision makers often do not need complex and nuanced solutions to their problems. What they need is concise and focused and actionable and explainable results provided within their decision cycles. Before I mentioned the trade-off between timeliness and precision, well, there's also the trade-off that my management sort of helped me understand, which is the trade-off between precision and simplicity. Simplicity for the sake of the consumer. So the best answer to a decision maker is not necessarily the most precise one. Often it's the answer that, of course, is precise, don't get me wrong, but it's also understandable too. And that is the last point I had to make. So at this point, I'd just like to thank you all for letting me speak and your attention. And I'd be happy to talk during the social room periods that we have.
Thank you, Major Maxine. It's always great having a service member speak at our conferences. So our next speaker is me.